In between, we're touching doorknobs, water fountains, and each other.
Matt.
Mom?
No, go up to your room, honey.
So we have a virus with no treatment protocol and no vaccine at this time.
You had a seizure this morning, Beth.
Does she have a history of seizures
No.
and allergies?
As of last night, there were 32 cases.
Unfortunately, she did die.
Right. Can I go talk to her?
Mr. Amoff, your wife is dead.
What are you talking about?
Hello, I'm Carlos Pachay, and alongside with my partner Bradley Crofts, we're going to discuss recombining DNA and biological warfare. The film Contagion provides a fictional recreation of many of the concerns that were prevalent during the 1918-1919 Spanish influenza epidemic and would cascade into any biological attack. Militaries have spent most of human history confronting microbes without knowing what they were. In the last century, militaries around the globe have confronted and experimented with microbes in the quest for defense from the invisible and as weapons to strike down enemies. DNA recombination is a very modern concept. Viruses and bacteria have undergone RNA and DNA recombination on their own as part of evolution. Modern science allows for a slicker method of accomplishing this. Normally, recombination is done for the benefit of mankind, but science can also use it for biological warfare.
We now understand that viruses and bacteria mutate. This was not well understood in 1918 when the Spanish influenza made its first slice through the population of the United States. This flu, besides being highly virulent, struck hardest on young adults who would normally have been the best able to resist the effects of a disease. Its impact on the front lines was lost among the fatalities that had already occurred there during World War I. The lack of a common understanding of the events from 58 years earlier and the poor handling of the media by the administration led to a poorly executed vaccine program. 33 years later, the government faced a similar dilemma with H1N1. Although better handled, it again faced stiff public resistance, which could portend similar difficulties in the event of a biological warfare event.
Bacillus anthracis has been a constant source of human disease. Because it is able to make endospores, it is an ideal bacterium for weaponization, since it has a better chance of surviving a bomb detonation and being distributed into the air. Scientists have looked at recombining DNA to form various strains that could increase its virulence. As such, it was used for experiments during World War II on a Scottish island that was not cleared of anthrax until 1986. More recently, in October of 2001, letters with anthrax spores were mailed to various people in the USA. The following audio clip is of Professor Richard Kame of University of Northern Arizona discussing his involvement with the FBI to determine where the anthrax may have originated. The investigations all pointed to Fort Detrick, where the military has a hospital and laboratory to match what the CDC has for studying highly lethal disease vectors, such as anthrax. The military, of course, soon found itself preparing for a war in Iraq and needed to protect its soldiers from the potential use of anthrax by the Iraqi military. This led to a highly controversial vaccine program that only worked as well as it did because the military discipline.
Aside from anthrax, military fiction and the occasional news report reflect concerns that scientists somewhere could develop a virus or bacteria that could easily survive the launch and re-entry of a missile and be distributed in such a manner as to begin to infect humans. The main problem with using a biological weapon is that microbes cannot distinguish between humans. As noted with the Spanish influenza, soldiers on both sides of the line fell victim to the disease. Unleashing a biological weapon has the potential to inflict casualties on the side that first used the weapon. One aspect that scientists involved in biological weapon research may be considering is finding a disease for which the side using the weapon has a preponderance of natural immunity. For example, people with the trait for sickle cell anemia are resistant to most strains of malaria. Finding a disease agent for which a specified group had high natural immunity would be ideal for any nation working on an offensive biological warfare program. Independent of the research discussed, microbes continue to evolve, and with the use of antibiotics along lines that have greater implications for the health of the military and society as a whole. Improvements in understanding of DNA and the spread of technology make it more difficult for nations to prevent the possibility of a rogue nation or group from using biological weapons in the future. Human evolution and the ability to create vaccines may not be able to keep pace with research into biological warfare. Even though Fort Detrick was involved in the 2001 Anthrax scare, it, along with the CDC, are the entities within the government that would be best positioned to prevent a devastating epidemic.
Throughout history, governments have struggled with containing disease outbreaks. Vaccine programs, since the large-scale containment of polio and smallpox, have frequently met resistance from the public. Quarantines in the Middle Ages were only marginally effective at preventing the spread of the Black Plague. And in today's highly interconnected world, stopping commerce would lead to widespread famine, especially in major urban centers. As such, it would likely fall upon the military and the CDC to quickly establish rules and regulations to allow some movements of people to ensure the movement of food, water, and essential supplies, but to limit the amount of contact to prevent a biological warfare agent from having a more devastating impact on the country than did the 1918-1919 Spanish influenza.
As discussed, viruses and bacteria have played a part in human and military history. Even when people did not understand diseases the way we do in the 21st century, they were able to devise means to spread fear and death. Understanding microbes and their potential role in natural epidemics or biological warfare will be important into the future. While we cannot control the research that others may do to inflict harm on the United States or any other country, we can continue to do research on preventative measures which could hasten the development of a vaccine. Similarly, having a well-educated public provides governments with the ability to quickly explain plans to control an outbreak when it occurs without generating widespread fear and untold complications in bringing an epidemic to a quick conclusion.